Hi everyone, here is the next video in our array of videos that we've been making with arrays. And in this video, I'm not going to write any code, but I'm going to show you, we're going to walk through several algorithms, or at least talk about the different types of data structures that we can implement using arrays, like application wise, what are the different things that we do with arrays? For example, we have a list of names maybe, right? So far we've only seen array of numbers. Next week we'll be working with char arrays, and then arrays of char arrays, or arrays of strings, which is nothing but char arrays. But right now, since all we know is a string class, we could have an array of strings. An array of strings, again, my array looks exactly the same. For example, if I had an array called string names, I don't know, 20 names or something like that. So we have an array with a capacity of 0 to 19, and let's say you have a list of names. The user has a list of names. They are trying to enter these names into my array. Okay, I don't know, we can have some names here. Let's call it Amit, Mike, Bailey, Priya. Okay, so they're not quite in order. Now, if I were to take these names and insert them into the array, right, alphabetically, then you would do exactly what you did with the numbers. So you would take the first name. If the array is empty, you're going to take this first name and put it in here. So here's count. And when the first name has been added, count becomes 1. So count is no longer here. Count goes here. And then you look at the next name, and we compare the string. So here's where all the comparisons start coming in, right? So it's a little different, and you're not going to have to worry about this. This is just an example to show you. You compare Amit with Mike. You compare really A with M, and you see if this is less than this, then we move. So it's exactly what we did before. If this number was less than the number in the list, we moved, right? So we start with a variable called pos that starts here. If this A is less than M, then we move it from here to here. Then we look, if it is less than count, we stop. And so we're going to add Mike here. So same algorithm, just a string of names. Then we go through, we read the next name, Bailey. Then we start pause at 0 again. If A is less than B, which it is, we move. So pause has moved to the next one. We're looking at this. M is less than B is false. So we're going to stop here. And then we want to do this act of shifting. So we are going to, not sure why my thing is not working. Okay, there we go. So we're going to now start. Pause is going to be here, which is really where it was. Then we're going to shift till the end of it. Count shouldn't be here. Ideally, count is here after we added Mike, right? So then we go through this process of shifting. Mike has been copied here. Count is no longer here. Count now has been incremented, and we have added Bailey here, right? And so on and so forth. So this is one of the applications, and this is how you would take a list of strings and insert them into an array. Okay, now what else can we do? What other data structures can we implement with arrays? There are other things we could do. You've heard of stacks, queues. They all have certain ways in which they are implemented. So with an array, you can do things like you did before. You can randomly insert, which we've done before, or you can insert them sorted, which we also saw before, or you can remove from a list. But if you had a rigid data structure that said you can only do things a certain way, then we have to essentially see how we can implement that here. So let's say we have an array that needs to be filled with whatever numbers. We'll stick with numbers. This is called list. And let's say we are trying to implement a certain data structure where it's a stack. For example, a stack looks like this, a stack of books, right? You put books on top of one another. They go like this. So if this was 0, 1, 2, 3, the first book would go here. The next book goes right on top. So it's the same as just if I were to do that sideways, I would just insert, which is the same as inserting a number, inserting a book here, and then incrementing count. I'll call my count just C, so it's easy instead of having to write count. So count goes here. Then I insert the next one on top. Okay, it doesn't matter. It may not be sorted. This is not about sorted. This is just about a stack. And every time I add something, it goes in the top. It goes in the top. And then this is my count. So count is sitting at 4, for example. So I've put in a whole bunch of things. And here is count. Right? Now, in a stack, if it is a stack of books, if I want to take off something, what would you do? You would just take it off the top of the stack. So this would be gone. This would be gone. You can just randomly take something from the bottom of the stack. If you want to take something from here, and if I have some things here, and if you want to take it from position 1, then you have to get rid of this, this, and this, right? You can simply say, well, I'll just take this. So if you yank a book out of the middle of the stack, what happens? The ones in the top fall off. So that's really not, okay, so the way a data structure like a stack has to be implemented is you always, so if you were to translate this to an array, and if we were to write a program for it, so I'm going to do the algorithm for it, and then eventually we'll write part of the program for it. But this is all about algorithms and trying to figure out, if I were told to implement something like this, how would I do it? So if I told you, you could always add at the end, and for the removing, you always had to remove from the top. So if the user said, I want to remove 4, okay, that's easy enough. You're just going to decrement count by 1, and you are going to set this to 0, and that's good. We've taken off the top now. Now, if the user says, I want to remove the 6, then you have to take off the 5 and the 6. And so count would really be, all this should be gone. All this should be set to 0, and count should really be here. And there's only one number left in the count. Okay, so for example, if you had a list like this, 12, 6, 7, 13, 5, and then count was here, 0, 1, 2, 3, 4. So count is at 5. And anytime the user adds, it's always going to be added at the end. Okay, it's always going to be added at the end. This is count. Anytime they want to add, we're going to add at the end, increment count. Anytime they want to remove, you're going to remove everything off the top until that point. If they say, I want to remove 7, then all of these should be gone. Your count should be here. All these should be set to 0. Now, in my list of elements, in my stack, I only have 2 elements left. Okay, so that's one of the possibilities. Now, the important thing here is to think about, where did we do the shifting? Okay, you may not have to do the shifting at all times. Sometimes you may have to shift, sometimes you may not have to shift. So think about it. For removing, for adding, I didn't have to shift anything, because all I am doing is, if this is my list, in this particular data structure, I'm always adding at end. So if count is sitting at 0 and there's nothing in my list, and user says, I'm going to add to the stack, okay, you add here, count moves to the next one. You add here, count moves to the next one. You add here, count moves to the next one, right? So now count is sitting at 4. I have 4 elements in my list, so I'm always adding at the end. I didn't have to do any shifting. But when I remove, for example, if I want to remove 8, then I need to remove these 2 as well. So I have to figure out an algorithm, somehow figure out something that can say, okay, if I'm going to move from here, I just want everything from that point removed. And how you figure that out? You may shift, you may not shift, because in this case, remember, we are just setting all these to 0, and count gets pulled back to that position. So you find some kind of an algorithm that's going to do the same thing. Now, that's a stack. What about a couple of other different algorithms where last in, first out? Okay, last in, first out is another data structure. The stack was the last in, first out. So that's what we just did, right? So if you think about it, you keep adding. The last book is the one that comes out first. So that's really not what I want. So let's start over. How about first in, first out? Because we just did the last in, first out. First in, first out says, okay, we add, here's my array. The user says, okay, here are some numbers that I need to add. And you're going to keep adding them. Okay, so we're just going to add them here, 5, 6. They just want it in this order. It goes in the same order that it is listed here. So count. Now, who came in first? 5. So if you had to remove something, it has to be removed from this end. So 5 has to be removed first. If you want to remove 8, then you need to remove 5 and 6 and then remove 8. You can't simply remove 8 and shift all these here. So what I'm saying is, in the first in, first out data structure, in order to be able to add, it's easy to add because you're just adding at the end, right? Everything is just getting added to the end here. But if I'm going to remove something, I have to remove it from the front only. So if the user says I want to remove 5, then the list is going to look like this when we're done. 6, 8, 1, 2. And the count has reduced to 4 because we just removed an item from 5 in my count. Okay? If the user says I want to remove, get rid of all this stuff. So get rid of this as well. Count is 5. The user says, well, I want to remove 8. Then my list is going to be like, I'm going to remove all of these in front of it, and 8 is also gone. So my list is now only 1 and 2, and count has moved over here. So from 5, I removed 3 elements, 5, 6, and 8. 5 minus 3, count is 2. I'm left with 2 elements, count should be pointing to 2. So now this is a little bit of a different algorithm again. So to be able to remove all of these in front of 8, I need to somehow figure out some algorithm to shift this 1 all the way here. And so anything after this number that needs to be deleted has to be moved all the way to 0. And then this would be moved to 0 plus 1, which is the next position. And if you have more like that, you keep going until the end, until you reach count. So there are different types of algorithm that you can come up with. Don't get stuck on the shifting only in one way. There are multiple things that you can do with an array. You can mimic different data structures. So what I recommend that you do is you take one of these examples. In my next video, I'm going to write code for part of this. But if you really think about it, this is really what is there in your assignment and in your midterm practice and in your actual midterm. It's you thinking about, what can I do? How can I apply the things that I have learned? How can I apply a for loop to see how I can move this number that is after this position? We obviously will know what this is. So you mark del pos, for example, and you're going to say, how do I figure out how to get all of these numbers after del pos until count? Again, it's a loop, right? For I equals del pos plus 1, I less than count, I want to do something. I want to take the value here and move it to 0. And then I want to move the next value to whatever is 1, and so on, right? So there is a pattern, and you find the pattern and you try to figure out how to write a loop that will achieve what you want. So there's no, just because we do delete and shift and delete, don't get hung up on that. Your goal is to be able to take that loop, that process that we have learned, and apply it to all of these different types of things that we can do with arrays. And these are some of the different data structures. And this is really what you do as you go through 162 and 260. You're just trying to figure out algorithms on how to do different things with items, with lists of items.